Okay, so welcome to CS 519 Applied Machine Learning. I'm your instructor Liang Huang from School of EECS at Oregon State. Okay, so I'm sure you have heard of the term machine learning, but you probably did not realize that machine learning is used almost every second as we speak now in your daily life. So Bill Gates once said that a breakthrough in machine learning would be 10 Microsofts, but today we think this is a very, very big underestimate. A breakthrough in machine learning probably is worth 100 or even 1,000 Microsofts. Well, if you do Google search, you use machine learning to rank the search results. If you play Go, there's the big breakthrough of AlphaGo a few years ago. And then if you use email, there's spam filters that use machine learning. If you use Alexa, that's machine learning as well. And face recognition, machine translation, and the Google new camera, and the stock market is often predicted using machine learning techniques. And finally, self-driving cars. Well, except that we had a few accidents recent time, but still we hope that in about 10 years time, or maybe even faster, fully autonomous driving will be the reality. Well, let's talk about AI as a superset of machine learning and the other subfields within AI. Because right now AI is super hot, and often people kind of equate AI and machine learning, which is not the right thing to do. Machine learning is a subfield within AI, and other subfields within AI include natural language processing, computer vision, robotics, planning, AI search, data mining, information retrieval, blah, 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 many, many fields. The three hottest areas right now are machine learning, natural language processing, also known as NLP, and computer vision, also known as CV. Well, they have intersections. So there's an intersection between ML and NLP, and between NLP and CV, and between CV and machine learning, and there's something that is intersected by all three fields. So these are different subfields within AI. But machine learning right now is the core, kind of the central subfield within AI that all other fields have to use a little bit of machine learning. For example, natural language processing uses quite a lot of machine learning. Computer vision probably uses even more machine learning. Robotics and planning and data mining and information retrieval all use techniques from machine learning. Today, it's very hard to find a field within artificial intelligence that does not use machine learning. That is, very shocking that machine learning is used at least everywhere within AI, and also outside of AI and outside of computer science as well. So let's look at the three kind of biggest breakthroughs in the history of AI in the past about 20 years. So the first breakthrough was IBM's Deep Blue, which plays chess, and it famously beats human champion Garry Kasparov in 1997. And that system used AI search, which I listed here as a subfield of AI, but interestingly, no machine learning at all. So all the rules and weights are hand engineered, and it's only a search algorithm that is playing the central role in that system. About 2011, there's IBM Watson, and that is also a very famous breakthrough, which beats human champions in Jeopardy, that question answering game. This system is mostly about NLP, this field, natural language processing, but it uses some kind of little bit of machine learning, but not too much. Now, last year and the year before, there's a huge breakthrough that is from Google DeepMind that plays AlphaGo, and it beats human champions in Go, which is a much harder game than chess in terms of space complexity, in terms of search space. That system is heavily based on machine learning. It uses two of the kind of most exciting subfields within machine learning, or most advanced subfields within machine learning. One is deep learning, and the other is reinforcement learning. So DeepMind is a company, is a startup that is built upon the single idea of combining deep learning and reinforcement learning to do deep reinforcement learning, and it was acquired by Google a few years ago. And plus AI search, because in order to play any game, you have to do AI search. But the breakthrough was really in deep reinforcement learning, because the techniques, the AI search techniques that used in AlphaGo was around before deep learning, but it was just in DeepMind that they combined deep reinforcement learning and AI search that made it so effective, so powerful, that beats every single human being by a very large margin. So as you can see, the progress from Deep Blue to Watson to AlphaGo, you can see there's more and more machine learning used in these breakthroughs, from no machine learning at all to a little bit of machine learning to like totally based on machine learning. And you can imagine the next breakthrough, maybe in autonomous driving, in maybe natural language interface, whatever, has to be heavily based on machine learning as well. And this is a funny story from a friend of mine who took an Uber ride, and the driver told him that, see, when AI comes, I'll be long gone, being replaced by these autonomous cars. But the programmers in those companies will be too, by automatic program generators. And that kind of conversation can only happen in San Francisco. And here are some jokes about when machine learning fails. So in particular, I kind of collected these jokes from my own research field, which is natural language processing. So for example, if you do translation and translating from Chinese to English, you can see a lot of funny signs in China when the English sign or translation actually reads very funny. So slip carefully, fall into water carefully, blah, blah, blah. And you might wonder why Chinese people always ask you to do these things carefully. It's because, well, it's all because it's machine translated. It's not human translated, right? So even today, if you try this 小心滑落 on Google Translate, you'll get slip carefully or carefully slip. So even today, they haven't fixed the problem. And this word, if you don't understand Chinese, this 小心 means caution, which can mean two different things. Be aware of something, or be careful not to do something, depending on the next word or phrase. Being noun phrase, that is, be aware of something, like be aware of dog, or be cautious of whatever. If it's followed by a verb phrase, however, it should be careful not to do something. All right, but Google doesn't. So machine learning can be very funny. So this is a kind of explosive dog, and this is my all-time favorite. This is a cafeteria in China, and the English title says translate server error. See, human beings are even using machine learning techniques even when it's not available, right? So it's clear evidence that machine translation or machine learning in general is useful in people's daily life. Okay, that's the end of part 1.